Swayam Prabha. Digital India. Educated India.
Now our discussion will be on sampling techniques. What is the purpose of sampling? To anticipate how the material is going to perform in service. This is something we always wanted to know. How it is going to perform in the service, that is when it is being used. And we need to check whether the items or the articles that we have produced or we are buying, does it meet the specifications which were supplied or not? Because ultimately a buyer wants to check whether the item that he is buying, is it really meeting the specification he has already supplied? Similarly, the manufacturer also wants to know whatever has been produced by the production team, whether it is fulfilling the specifications or not. So for all this, we have to go for a sampling technique, because entire population of articles cannot be checked due to following reasons. And the reasons are, one is lack of time. This is something that we really cannot test the entire population because we do not have time. It needs so much of time that an industry may not have that much time in checking each and every item. Then the manpower that is required. You need lot of manpower, lot of instruments to check each and every property of the items. And then obviously there will be a lot of cost involved also. The more you want to check, more time you require, more instruments, more people, and therefore overall cost of checking is going to be very, very high. And thus the population, entire population is not possible to be checked. The another important aspect is sometimes the texts are destructive in nature. There are two types of tests that we perform, destructive and non-destructive. So in destructive test, if I want to test the entire population, the entire lot is going to be completely damaged or it cannot be used. And therefore, we can only choose a representative sample of the whole population, that is lot, and then we can go for the required tests that we want to perform on it. So the sample is going to be a representative of the population. That is the most important thing. And hence there are two important aspects related to sample. One is how many samples we should draw, and once we have fixed that this many samples need to be drawn for subsequent testing, how do I draw the samples when I have a large number of items in front of me? What procedure we should choose? That is also equally important. So the procedure part is something we are going to discuss. The other important aspect also is the samples that we should draw should be unbiased. That in the selection process, we should not be biased. That is also another important aspect. That I am not going to choose the better looking items or the items of a particular color only. Things like that, that there should not be any bias in this whole selection process. Now we'll explain or define certain terms which are used in sampling. First term is consignment. So consignment is the quantity of material delivered at the same time. That is one consignment. Each consignment may consist of one or several lots. A truckload of fabric roll may come, so that becomes one consignment. Or a truckload of bale cotton may come. That is also a consignment. It may be one truckload of 5 truckloads or 3 truckloads, whatever it is. But at a time, whatever is coming, that is one consignment. Then comes lot or batch. All containers of textiles, that is fiber or yarn or fabric or garment, whatever they are, of one defined type and quality will be considered as a lot. The material is presumed to be uniform and representative of the population. So that is how the lot or a batch is defined. Next comes laboratory sample. Materials to be used for carrying out test in a laboratory. It is chosen by following very appropriate sampling method. So ultimately, we have to perform the test in a laboratory. So whatever samples are chosen from the lot or from the batch, they will be considered as a laboratory sample. Next comes test specimen. It is used for individual measurement and derived from laboratory sample. So once the laboratory sample arrives in the laboratory, then we may cut specimens from that particular sample. Like we can cut the specimens of fabrics in order to find out some property of the fabric in the laboratory. So from a roll, we may cut certain specimens, and each specimens will be then tested for maybe strength testing, or maybe abrasions testing, or maybe color fading, whatever test we want to do. So we have to take some specimens. So they are known as test specimens, and generally they are prescribed what should be the dimensions of those specimens in terms of length and breadth, and these standards are specified. So accordingly we cut the specimens and then we go for testing. So these are called test specimens. The other term is package. Package is a very common term. Elementary unit within which container, within each container in the consignment. It is the elementary unit. So these are all packs. The package of yarn. So in a consignment, there is a container or boxes made of cardboards, and each boxes they will containing a lot of bobbins. So they will be considered as package. It could be cheese, it could be corn, and they will be considered as package. It could be garment items also. So each individual item, or you can say elementary units within the container, will be considered as package. And what is container or case? A carton or a box or a container made by wood or made by some other material. So that's a container. Container is also very, very common term that we use. So these are the terms which are used while we discuss about the sampling. Next, sampling type. There are 4 types of sampling as it is shown here: random, systematic, stratified random, and cluster. These are the 4 types of sampling techniques, and we are going to discuss each of them one by one. First, we start with random sampling. The random sampling also can be done in 2 different ways. One is sampling with replacement, and the other one is sampling without replacement. In a random sampling, every item of the population has an equal chance of being selected in the sample. That is what is called random sampling. So we are not biased, and each and every item, the items which are there, all the items would have equal chance of getting selected. It's not that some items are suppose lying at the bottom of the box or container, some items are lying at the top of the container. It's not that we will pick up samples only from the top. In that case, we'll say we are biased because we are only removing the samples from the top layers. Similarly, we should not only select samples from the bottom layers also. So, if we follow such procedure, then that means we are actually biased. The idea is, the principle which we should follow, that each and every item, irrespective of their location within the container, each of them should have equal chance of getting selected. So that point we have to keep in mind, and there are 2 ways this random sampling can be done: sampling with replacement and sampling without replacement. Sampling with replacement means that we sample the first item and we put it back again. Again we sample another item and again put it back again. That means the population size is not going to change, remaining same. And sampling without replacement means the moment I choose a sample, I keep it, it does not go back to the population. So population size reduces by 1 item. We choose the second one and again we keep it separately. So population size reduces by 2. So if we follow this procedure, this will be sampling without replacement. So with replacement is, after the first selection, the item chosen is replaced, as I have already told you, and a second item is now drawn. Here the same item may be selected more than once. That possibility exists here, because once I put it back, it becomes part of the population again, and it may be selected again. The without replacement, as I have said already, we do not want the same item to be selected again. Therefore, if an item is selected once, it is discarded or it is kept separately after the first selections, and then we go for the second selection, then third selection, like that we go. Every time we select one, that is kept separately. So these are the 2 different ways that the sampling of the items can be done in the case of random sampling procedures. Now we are discussing a typical example to make the idea clear in front of you. Let us say we have to select 15 sewing thread bobbins out of 100 bobbins. to check whether the yarn strength is as per specifications or not. So suppose we have a small lot of 100 bobbins and we have to select 15 sewing thread to test some property. So how do I select this 15 out of 100? So there are 100 sewing thread bobbins, we know already. We level each bobbin from 1 to 100. So each bobbin will paste a number 1, 2, 3, 4, 5, 6, 7, 8 up to 100. Then use a table of random numbers to select 15 bobbins from 100. Now on the right hand side, I am showing you a table of random numbers. This table of random numbers is from Bureau of Indian Standards. So here is a random number table having 2 digits. We will discuss about how to choose random numbers in some other, as I move on, we will discuss in more details how the random numbers from these tables how they are selected. The selection process of random numbers also I will let you know. But you have to wait for that. It will be coming after few slides. Okay. So anyway, from the random number table, we will choose 15 bobbins out of 100. So when the bobbins are numbered, and then I am going to choose those 15 random numbers. And then once I have those numbers with me, I will select only those bobbins against which those numbers have been pasted. So in that cases, it will be completely unbiased selection of the bobbins. So every item in this case will have 1 upon 100 chance of getting selected. Every item will have equal chance of selection. Next, another example. Suppose in a cotton spinning mill, 30 cops are to be tested per day as taken from 6 to 12 ring spinning machines, each having 1000 spindles per machine. So we have 12 ring spinning machines and 1000 spindles. So that means there are 12,000 spindles on which the yarn is being made. Okay, and we have to go for 30 cops are to be tested per day because they are all running on the same count of yarn. So how to go about it? We have to make first 12 tickets for each ring spinning machine because there are 12 machines. So we'll have 12 tickets. Each ticket will be assigned to one particular ring spinning machine. And then we should have also 1000 tickets for identifying each spindle. There are 1000 spindles, maybe 500 spindle on one side and 500 spindle on the other side of the ring spinning machine. Total 1000 spindles. So we'll have also 1000 numbers, or you can say tickets, representing the 1000 spindles. First of all, what we should do, we should choose one ticket from 12 in order to determine the first ring spinning machine. Out of 12, we will first choose which particular ring frame number we are going to choose. So one ticket out of 12 will choose it, and this selection also can be done based on random numbers. So we can select randomly. Once it is done, then 30 tickets are taken from 1000 in order to identify 30 spindles from which bobbins are to be chosen from spinning machine selected in the previous step. So now we'll choose 30 tickets. That means I will get to know which spindle we should target to collect the bobbins. Each spindle is spinning the yarn and the bobbin is there on the spindles. So we choose 30 tickets. So 30 different numbers will come and they will be randomly selected. And now we will go to the ring spinning machine and remove bobbins from those spindles for which the numbers we have already selected randomly. And then finally tickets are replaced and this method is repeated further 5 times because ultimately you are going to select total 6 ring frame on a particular day. All 12 ring spinning machines are not going to select it. In this particular case example, 6 of them will be chosen and from each machine 30 spindles we are going to target. So we'll remove the corp from 30 production positions and then we'll test what is the count they are spinning. If the test is meant for just to know what is the yarn count this set of ring frames are producing today. So selection of the machine is random. Out of 12 we'll choose one random, then we'll choose the second one, then the third one. So this will be, so once I choose the first one will move out. Then out of the rest 11 we'll choose another randomly. Then that will be also taken out. Then we'll choose another. So fourth will be remaining now. So we'll choose another one more. So it is a way, in a kind, this is to some extent we can say because we are doing the selection without replacement. Once the first ring frame is chosen, whatever the number comes, suppose the number comes third. So third ring spinning machine will be chosen. So next selection is based on out of 11 tickets now left, we'll choose another ticket. This may come 7. So we'll take the 7th ring frame. From there we will collect the corps. Now 3 and 7 has gone. We are left with now 10 ring spinning machine. Now we'll choose another ticket. So like that we keep selecting the tickets, but we don't want that the same ring spinning machine is repeated today. Today we are going to select only 6 out of 12. So that is how this sampling procedure can be followed or can be practiced. So selection of the machine is random. Selection of spindle out of 1030 spindle also is done randomly. So you have to consult the random number tables. Now comes systematic sampling. It is not completely random. In systematic sampling, we partition n items comprising the population into small n groups of k items. Each group is having k items. So the entire population is first divided into n groups. And each group will be having k items. So therefore, k is going to be always capital N by small n. K is to be rounded to the nearest integer. If it is a decimal figure, we will take the nearest integer value. So small n is the number of groups and capital N is the population size. And the procedure to obtain systematic random sample, that is what you are going to discuss now. Select the first item at random from the first group of k items. So in the first group we have k items are there. We choose one item at random. If we have to choose 2 items at random, we can choose 2 at a time also. So whatever we choose, 1 or 2, we'll choose at random from group number 1. After that, how many groups will be left? We'll be left with n minus 1 groups. Then we'll choose the remaining item that we have to choose. How we'll choose it? By taking every kth item from the remaining population. If there are n groups, we have to choose, suppose, n number of items. So from the first group, we choose any particular item at random. And then we go to the second group, we go to the third group, fourth group. So none of the groups will not be avoided. We must select items from each and every group. So once the first item is chosen, we are left with now n minus 1 items, and that we have to choose from all the groups. So what we'll do? We'll do it by taking every kth item from the remaining population. How do I do it? Now this is what is going to discuss with an example. Let us look at this example. This is going to make the understanding clear. Suppose we need to select 20 bobbins from one side of a ring spinning machine, and it has 2000 spindles. Construct a systematic sampling plan. So it's a big ring spinning machine, almost 2000 spindles are there nowadays, such big machines are there. So on one side we have 1000 spindles. So, but we have to choose from one side. How many bobbins? 20 bobbins. That means n is going to be 2000 by 2, that is only 1000. Sample size, small n in this case, is 20. That means we have to make basically 20 groups, because I will divide the entire population, 1000 population, into now 20 groups, because we finally need 20 samples. So 20 groups we will make. So each group will be having how many items? K. K is the group size. It will be capital N by small n, 1000 by 20, that is 50. So we'll have 50 is going to be the group size. So we have 50. So this is what is represented in the figure below. Like this is the one side of the ring spinning machine. We have 1000 spindles, and you see we have group 1, then group 2, group 3, group 4, group 5. It goes up to group 50, and each group is having 50 spindles. So we have 1 to 50 making group 1, 51 to 100 making group 2, 101 to 150 group 3, like that it goes. So entire population of spindle on one side of the spinning machine is divided into 20 groups. Now from each group I'll choose one spindle. What do we do? Select. So since we have to divide it into 50 groups, so all spindles will be numbered sequentially from 1 to 1000. So this we have to do in advance. The spindles starting from left hand side to the right hand end, all the spindle has to be numbered starting from 1 to 1000. Then select a random number from first 50 individual spindles. So from this group of group 1, which is this group, there are 50 spindles here. What we will do? Out of 50 numbers, we will choose one number randomly. Suppose that number happens to be 3, our selection is. That means we'll choose the third spindle, which is shown here by the orange color. So we'll choose the third spindle. If it happens to be 7, then we should have chosen the 7th spindle. If it is 23, we should have chosen the 23rd spindle. And now onwards, as we go from group 1 to group 2, the next spindle will be 3 plus 50. That is 53rd individual bobbin should be chosen from the next group. So we'll go at the interval of 50. So 3 plus 50, 53rd, and then 53rd plus 50, 103, 103 plus 50, 153, like that will go on. So from each group, the third spindle is being selected. So whatever bobbin is there on the top of that particular spindle, we'll remove all those bobbins, and that will give us 20 selections we'll be able to make. So this is what is known as systematic sampling plan, where the very first selection of the spindle or the bobbin is done at random, and then onwards the subsequent selections goes at the interval of k, where k in this case is 50, that is the size of the group. That's how we move on in this particular type of sampling procedure when we follow. This is what we generally do. Another example is, these are very practical examples. Make a sampling plan for checking the count of roving being produced on 5 roving frames, each having 96 spindles. The plan should ensure that all spindles are checked within a month of 26 working days. So some conditions have been laid out. In the spinning machine, in the factories, actually, the sampling plan also should ensure that all the production positions, they are checked within a month, or within 3 months, or within 6 months. There is some standards which are followed, which may vary from industry to industry, but every industry has a policy that whatever machine they are using, it could be sewing machines, it could be spinning machines, it could be looms, whatever it is, each and every loom or spinning machines or roving frame, they must get checked from time to time, so that we can also identify whether a particular spindle is producing a wrong yarn or wrong bobbin, or giving too many breaks, whatever. No, in that case, some maintenance can be carried out on that particular spindle, whether it's, or that particular sewing machine, or it could be that particular loom, whatever it is. So in this case, this particular thing has been given, stated that spindle must be checked within a month, and a month of 26 working days. That is, considering that there are 4 days when the factory is not working, which is generally not true. Factories actually work or 24/7 or 365 days. But anyway, this particular case, this is what has been stated. So how to go about it? The preferable sampling method will be systematic sampling, where every position is checked at least once within a month. So total number of spindle is how many? Roving frame, each machine has got 96 spindles. So total I have 5 into 96, therefore 480 spindles. Now number of spindles to be checked per day, because on 26 days I have to complete checking the bobbins being produced by all 480 spindles. So each day I have to check 480 by 26, 18.5 number of bobbins. It's a fractional number or decimal figure. Obviously 18.5 bobbins, it will be either 18 or 19, it cannot be 18.5. So number of spindles to be checked per machine, if we go by this, that is 18.5 by 5, because there are 5 roving frames running. So it will be, this figure is coming to be 3.7. So 3.7 roving bobbins we have to check per machine. Obviously this is also a decimal figure. We cannot, number of bobbins cannot be a decimal figure. So you have to only go for integers figures. So what we'll do, we have to take 4 roving bobbins from each speed frame per day. Therefore, if I do this on the first day of bobbins, on spindle numbering 1, 2, 3, 4 are checked at all the machines. So if I have 5 machines, one after the other, from each machine, bobbin numbering 1, 2, 3, 4 are checked. So we remove 1, 2, 3, 4 from roving frame number 1, same spindle number from roving frame number 2, same spindle number from roving frame number 3, like that we go on. On the second day, we decide to check 5th, 6th, 7th and 8th spindle. Like that we move on. And on the 24th day, we'll choose 93rd, 94th, 95th and 96th spindle are checked. So by 24 days actually, all the spindles will be covered or all the bobbins will be covered. So that is the advantage we'll have, that even in 26 days, within 26 days, because the is not exactly 26 days, within 26 days I will be able to cover if I choose 4 bobbins at a time from each. If I choose 3 bobbins at a time, then we will not be able to cover all the spindles within 26 working days. Because if we check 3 and there are 5 machines, so 3 into 5 we are choosing 15 bobbins per day, and if there are 26 working days, then in 26 days how many bobbins we will choose, we will be able to cover. It will be 26 days, each day 15. How much it will be? It will be 390. So, but we have how many? 480. Actual number of spindles are 480. So if I go by 3 per day, we will not be able to finish checking all the bobbins from all the spindle in 26 working days. So that's why we are not going to go for three rovings, but we are going for 4 rovings. This is the reason.